Students, okay, today we will discuss about t-test, how we'll apply t-test in applied data sets. So basically t-test is also known as the student t-test or unpaired t-test. We apply t-test by comparing the mean between two groups. If your data set is following normal distributions, then we apply the t-test. So we have one examples. We will discuss about the example, which is like from this class we collect the hypothetical mean of the IQ, average IQ level of 100 of this class. This is our hypothetical mean, and next step will collect the samples. Suppose we select the randomly 10 sample from this class and we measure individual IQ level. See here like 70, 120, 110, 101, 88, 83, 95, 98, 107, 100. This is the sample IQ level we obtained from the samples who has selected from the given population groups. So see how we'll solve such type of problems with help of t-test. See examples. If we have such type of examples, such type of questions, so we'll start from the hypothesis. First of all, we need to write the hypothesis about like null hypothesis. In our case, null hypothesis is mu is equal to 100. Null hypothesis means null means zero, nothing. That means there is no association between hypothetical mean and sample mean. So we have written here mean is equal to 100. Alternative hypothesis mu does not equal to 100 means there is two tail. This is two tail test. There is two options. It may be greater than 100 or it may be less than. So as we know the t statistics, t is equal to x bar minus mu divided by s divided by under root n. Here s is known as the number of standard deviation, n is known as the number of samples, x is the sample mean, and mu0 is known as the population mean. Here n minus 1 is known as the degree of freedom. See how we'll solve this problem. See, we have given example x is equal to this 10 samples, IQ level is given. We added all the values and added our 972 divided by 10 number of observation. We got 97.2 is mean. Here for standard deviation calculation, we calculate x minus x bar. Column means this is x1, x2, x2, x1 minus x bar, x2 minus x bar, x3 minus x bar. This is like this. Then we need to square because we want to calculate standard deviation. So we have in given formula we need to calculate x minus x bar. That's why we squared corresponding value of the given x minus x bar column. Next, as we know, given the problem, n is equal to 10, x bar is equal to 97 divided by 10 is 97.2. We just need to put the all value in given formula. We'll get this is s is equal to means standard deviation under root 203.73. We just put all the values in formula. We'll get this. Once you will put the value 97.2 minus 100, so we will get minus 2.8. So we taken modulus value, that's why we ignore the negative signs. We got this value and this 0.62. It is known as the calculated value. So once we know the calculated value, with help of table value at 95% confidence interval means 0.05 level of significance at 9 degree of freedom, we find out 2.262 is the tabulated value. As we know the conditions, if calculated value is greater than tabulated value, we reject the null hypothesis. But in our case, calculated value is less than tabulated value, so we accepted null hypothesis. That means, see the conclusion. See, there is two important points. once you take the right correct decision and you write the correct conclusion. So in our case, we consistent with the assumptions of mean IQ of 100 in the population, means whatever hypothetical value we have taken from the class students and sample students, means hypothetical value is correct in our case. Okay, I hope it's clear. Thank you.